Hello, I'm Mr. Howard. Alright, this is part 3 of your Unit 7 Pre-Calculus review over quadratics. We're going to work the last two problems in your review, which are both word problems with quadratic applications. Okay, so we have question 8. A pig pen is to be built up against the long side of a barn with the barn serving as one side of the pen. There is a maximum of only 60 feet of fence material to make up the other three sides. The side of the pen opposite the barn is to have an 8-foot gap so as to accommodate a gate. What should be the dimensions of the pen in order to maximize its area? Okay, so we're going to maximize the area. What is the maximum area? Okay, so let's draw a picture. It's always a good idea. So we have the barn right here. So we have our other three sides like this. I'm going to leave room for that gate that it talked about. So this is an 8-foot gate here. This whole side is length. We'll put width here and width here. Okay, so there is our picture. Alright, so the first process, or first step that we used before is we want to put in this constraint. So we only have 60 feet of fence. So that means that W plus W plus our length minus 8. Okay, this whole length minus the 8 feet of the gate is for the area for the gate is supposed to be equal to 60, right? We have to subtract this 8 out because that's going to be open fence. So our full length, we're only going to use this much of the fence, right? Those two spots there. Okay, so that's why I have minus 8 in here. You're not plus 8 because you're not using 8 foot of fence. There's actually, this total dimension here is going to be 8 less than what we're showing here because of this gate that's going in. Okay, so make sure you understand that. Alright, now the next step was we wanted to solve for length in terms of W so we can get down to only one variable. So if I work this out, and I'm going to do this fairly quickly, but we have 2W right here, and so we're going to get rid of that 2W. So that's going to be, we already have 60 over here, right? So we're going to get rid of this 2W, move it over to the other side, I should say. So that's minus 2W, and then we have a minus 8 over here, so when we bring it over here, it's a plus 8. Okay, so let's combine all that, so we get L equals negative 2W, 60 plus 8 is plus 68. Okay, so there's our length. We want area, right? So area is always length times width. So in our case, area equals our width right here times what we are subbing in for length, which is this chunk right here. So negative 2W plus 68. So we distribute here. And if you need to watch the video again on how we do these word problems where I go through a little more detail, go ahead. I'm moving pretty fast here. So that's negative 2W squared plus 68W. Okay, so now we have our area equation. So we can put that into our calculator. So I'm going to write it over here so it's not covered up when we pull the calculator up. So negative 2W squared plus 68W. So we want to maximize this thing. And in order to set our window quickly, I'm going to apply what we've done before, which is negative B over 2A to find our vertex. So negative B is going to be negative of this number, so negative 68. 2 times our A value is negative 2, so negative 2 times 2 is negative 4. So let's see, that would be 10, it would go in 10 for 40, and then 28 would be 7, so that would be positive 17, right? So the x coordinate of our vertex is 17, so we can plug that in real quick. So we get, clear this out, so we get negative 2x squared plus 68x, and I'm going to jump in my table to an x value of 17 because I know that's my maximum x value, that's my vertex value, so 17, and I want to find the y coordinate there so I can set my window. So again, you can look back at that video for more detail. Whoops, on the table there. So that would be 578. So my vertex is 17 comma 578. 17 comma 578. So this will help me set my window now. That's important, so I can graph this quickly. So let's see, so we'll do say -2 to double this plus a little bit, so double that would be 34, so we'll make it x max 38. Y minimum, -2 is fine. We don't care about any negative parts. Our y-axis is our area, remember. Y max, go a little above that, so we'll call that 600. So we graph this thing. Bring this over. We already found our vertex, which is the most important part, but I am bringing the graph over so that you understand what we're doing there. So our vertex was this right here. So 17, 578. And this is feet of fence, right? We were in feet, so this is our width, and that was in feet. And this is our area, and that would be in square feet. Okay, so our maximum area, which is what it actually wanted, is 578. So area max is equal to 578 square feet. So 578 feet squared. And the dimensions that we needed, our width is equal to this value right here, 17. So our length that we need, we have to sub in back to this equation right here. So we need to sub in that 17 right there. So that's negative length equals -2 times 17 plus 68. So length equals -34 plus 68. So that's going to give me a value of 34 if I work that out. Okay, you can check me on that, but it should be right. So here we have it. So we want a width of 17, a length of 34, and max area of that would width of 17 here, and length of 34 with this part and this part would give us the max area for this pen of 578 square feet. So those are our two answers. All right, let's move on to the last problem in our review, problem 9. Alright, so we have problem 9 here. This is a little bit of a complicated problem to set up, but it makes sense once you actually set it up. So it says, an object is dropped from a hot air balloon that is ascending at the rate of 2 meters per second, so that's important. When the balloon is 200 meters above the ground, okay, so we're going to be, I'm just going to tell you now, we're going to be using this equation that I will give you. You don't have to worry about memorizing this, but it was y sub 0 plus v sub 0 t plus, or pardon me, minus, there should be a minus right here, minus 4.9 t squared. That was our, when we're talking meters and seconds, this is our equation for an object that is affected by gravity. Okay, so that's going to have to be given to you. It's not given in the problem, but I will give that to you. Okay, so we just need to identify our y sub 0. So y sub 0 is going to be this 200 because that is where the object is actually dropped from. That's the initial height, which is what y sub 0 is, so that's 200. Our v sub 0 is the initial velocity that the object is thrown up in the air at, so that would be 2 meters per second. So that's just 2. Basically, we have a hot air balloon with, this is a terrible drawing, but anyway, a basket. So this balloon, we're moving up at 2 meters per second, and we are 200 feet, so 200, or not feet, but 200 meters above the ground, and we are basically just dropping this object, so it's going to fall to the ground. So its initial height was 200 meters, and we were moving up at 2 meters per second, in the balloon, so the initial upward velocity of this thing that we dropped is 2 meters per second. Okay, so that's what's going on. When you are given a problem like this, you just need to identify the initial height and the initial upward velocity, and then work it from there. Okay, so use a graphing calculator to graph this function and determine when it strikes the ground. How high is the object 2.3 seconds after it is released from the balloon? So we've got to we're going to have to find this in a minute, and then we need to graph it. Okay, and we need to find out when it strikes the ground. So several things that we have to do here. Alright, so we have a rough sketch. So let's get our equation. So our situation is y equals 200 plus 2t, that's a plus, that's a t, minus 4.9 t squared. Okay, so there's our equation for our situation. Alright, so if we put this in our calculator, so I'm going to slide my calculator over here for now, since we have our equation right here. So y equals, clear that out, 200 plus 2x minus 4.9 x squared. Okay, so at time 0, so that's going to be our y-intercept, right? When x is 0, our time is our x-axis. So at time 0, if we sub in a 0 for that t value and that t value, we're going to be left with only 200, right? Because that term cancels and that term cancels, so we're only left with that 200 when we sub in a 0 there. So our y-intercept is going to be up at 200. So we can go ahead and start setting an approximate window. So -2 is fine there. X max needs to come in. If we're dropping this thing from 200 meters, let's just set 10 for an X max for now. And we set our y-intercept, y minimum at -2, that's fine. Y maximum would be a little above our y-intercept. Our y-intercept, this is standard form, so this value gives us our y-intercept, so that's 200. Let's go a little above that, 210, and graph this thing. Okay, so there is our approximate graph. So instead of sketching it, I'm just going to bring this in right here. So here we have when it hits the ground. This time right here, this 0 is when it hits the ground. So let's use our calculator to find that. So I'm going to graph y equals 0 here. And I don't mind if you use your calculator on these. These are calculator based applications. So then we graph, and we use second trace, and we're going to use the intersect, option 5. First curve, the parabola. Second curve, this line down here, enter. And then the guess, I'm just going to hit enter, and it should find this one. Okay, so I'm bringing this in, and there is our 0, which means it's hitting the ground, because remember, this is our height above the ground, our y-axis, and our x-axis is time, and that was in seconds, and our height is in meters. Okay, so we're hitting the ground, so that it hits the ground at, we'll call it 6.596 seconds. 6.596 seconds. So that's part of it. So hits ground. Okay, that's one answer. And then they want to know how high is the object at 2.3 seconds. So that's going to be 2.3. So we want 2.3 seconds. So we want when x is 2.3. So we want that height. It doesn't ask us at all for the maximum height or anything like that. So the last thing that we need to find is that value, and we can use our calculator. So we have the graph in here, and we want when that thing is at 2.3 seconds. So on the x-axis, an x-coordinate of 2.3, what's the y-coordinate? Basically, that's all we're doing. So second trace, we use value for that. So value. And x equals, we said 2.3 seconds, so x equals 2.3. Enter. And that gives us that last answer. So here it is right here. We're at this point right here. So we're at an x value of, so that coordinate right there is 2.3 comma this value right here, 178.679. So the height at 2.3 seconds after it's been dropped, at 2.3 seconds, is 178.679 meters. Okay, so there's our last answer right there, 178.69 meters at 2.3 seconds, and it hits the ground 6.596 seconds after it is dropped. Okay, so that's it for your review. So make sure you use this and you'll be ready for your test. See you in the next video.